Hi guys! Salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about mechanics of deformable bodies. At ngayon ay mag-discuss tayo ng isang problem about Poisson's ratio. Okay? So sa problem na ito guys, we'll be using the applications of the Poisson's ratio in determining for the stress when a tube that is inserted on a hole is subjected to an internal stress. And here is our problem. A 1.5 meter diameter steel tube with a wall thickness of 6 millimeter is inserted inside a rigid wall. Initially, there is a gap of 1 millimeter between the diameter of the tube and the diameter of the hole. Assuming that the Poisson's ratio is 0.2 and the modulus of elasticity of the material is equal to 200 gigapascal. So we find the following. Letter A, the internal pressure needed so that the wall will just fit the hole. And letter B, the tangential stress developed on the wall if the tube is subjected to an internal stress of 2.5 megapascal. Sa puntong ito guys ay siguro mas mabuti kung itong ating illustration, itong ating problem ay ma-illustrate natin para madali natin maipakita yung mga deformations or strain that will be caused by the stresses. Okay? So, here in our figure, meron tayo dito okay, a cylindrical tube, the diameter of which is given, given itong diameter nito, which is 1.5. And this tube is inserted on a hole, okay, rigid hole. And according to the problem, initially there is a gap of 1 millimeter between the diameter of the tube and the diameter of the hole. Siguro mas maganda kung ipakita natin asan ba ito tinatawag na gap. So, between the hole and this tube, meron daw sinasabi ditong okay, 1 na gap. Ito yung gap na tinutukoy natin. And considering that we have the Poisson's ratio of 0.2 as well as the modulus of elasticity that is equal to 200 gigapascal, we wanted to determine what would be the pressure inside, okay, to what pressure that this must be subjected so that this tube will just fit the hole. Ang ibig sabihin nun, itong ating side of the tube will just touch the side of the hole. Hindi ba? At yung second question naman, ang ipinapahanap sa atin dito, kung sakali daw na yung pressure naman ay maging 2.5 megapascal, what would be the tangential stress that would be developed on the tube? Okay? So, ipakita natin dito guys itong ating mangyayari. So, kunwari, meron tayong pressure dito, ang tinatanong dito, kung sakaling this will be subjected to pressure gaya ng ipinakikita sa illustration. Okay, ang hinahanap sa atin ito daw pressure nito so that itong ating tube will just touch the hole. So ganyan yung inaasahan natin mangyayari. So kailangan may ipakita natin dito that when the tube is subjected to an internal pressure, it will be subjected to two kinds of stresses. Meron tayo tinatawag na longitudinal at saka tangential stress na pwedeng ma-develop dito sa ating tube. Kaya, ipakita natin, kunwari ito yung ating major axis. We consider our major axis as our x and the y axis. Na kung saan, itong ating y-axis is the direction of the longitudinal axis of the tube. And, from here, meron naman tayo ditong direction of our tangent axis which is actually directed along the x-axis. That's perpendicular or parallel to the direction of the circumference. Okay? So, yung sinasabi natin na pressure, ay na hinahanap natin ay makaka-apekto dito sa dimensions ng ating tube, parallel to the x-axis and parallel to the y-axis. Kaya kung ipakikita natin ano yung maging epekto ng longitudinal stress doon sa dimension, okay, that is parallel to this axis and x-axis. So makikita natin that there will be an increase in the dimension, okay, that is parallel to this longitudinal axis, and correspondingly, meron siya ngayong decrease in the dimension parallel to the x-axis or the decrease in the diameter. Siguro mas maganda kung ipakita muna natin dito ano ba yung magiging epekto niya kung sakaling nagkaroon siya ng kay inanalyze muna natin ito tinatawag na longitudinal stress. So ganito yung mangyayari, no? So due to the stress, kay magkakaroon siya ng tinatawag na kay may stretch yung kanyang dimension ditong dimension nito. Pero napansin natin na umikli itong ating kay nabawasan itong ating diameter. Something like this one ang mangyayari. Okay? So, kailangan maipakita kasi natin dito yung possible reduction in the diameter. And the reduction in the diameter will be represented by the distance from this point to that point. And for discussion purposes, let me exaggerate this dimension. And tawagin natin ito na it is yung strain, tinatawag siyang strain in the x-axis caused by the stress parallel to the y-axis. So we call this as what? Strain in the x due to the stress in the y. So because of the stress along the y-axis, which is positive, okay, we expect therefore that there will be a reduction in the dimension along the x-axis, and we call that as strain in the x due to the stress in the y. At okay, doon sa ating napag-aralan, so this value will be equal to the product of the Poisson's ratio multiplied by the ratio of the stress along the y divided by the modulus of elasticity of the material. So that if we know the stress along the y, then and we are given this Poisson's ratio, then we can find the magnitude of this deformation, okay, or strain. Okay? Similarly, okay, since ang tinatarget natin ay ano yung pressure na ano yung pressure inside so that it will touch this part. So we have to consider naman what would be the effect of this tangential stress on the tube, di ba? So if we will be applying the tangential stress, we will expect that this tangential stress, it is directed parallel to the direction of the x-axis. Hence, it will cause an increase in the dimension along the x-axis, meaning it will increase in the direction or in the magnitude of the diameter. And up to what level, up to what point it will cause an increase according to the problem, since we are just looking for the value of P so that it will just touch or will just fit the hole, meaning this tangential stress will be causing a strain along the x, so that it will cause this side to just touch this portion or the side of the hole. Kaya kung ipapakita natin yan, assuming that we analyze now the tangential stress, so what would happen? Itong ating tube will now change in dimension, lalaki yung kanyang diameter uli, pero iikli uli siya because of the tangential stress. At kung ipapakita natin ngayon yung epekto nitong tangential stress doon sa dimension, okay, ito yung makikita natin. Kasi kung ito yung naging position niya after it has been subjected to longitudinal stress, therefore, from this point up to this point, it will become the supposed to be strain that will be caused by this tangential stress. And it will be called as the strain in x due to the stress in x. And this is equal to the ratio of the stress in x divided by the modulus of elasticity. So after you have analyzed the corresponding strain due to the stresses in the x and in the y direction or due to the longitudinal or tangential stress, then let us try to analyze what relation exists between this strain. You would find that the total strain that is supposed to be caused by the tangential stress, which is represented by this distance, would be equal to the magnitude of the two values, which is equal to the strain in x that is supposed to be caused by the stress in the y direction, and that of the gap, or the strain that is supposed to be caused by the gap. Hence, we would expect, therefore, that if that would be shown, okay, therefore, the strain in X due to the stress in X shall be equal to the strain in X due to the stress in Y, which is represented by the product of the Poisson's ratio multiplied by the stress in Y over the modulus of elasticity plus the added strain due to the gap, and that would be 1 over 1.5 or 1,500. You might be asking why it should be divided by 1,500. Kasi nga, yung gap natin is 1 millimeter. There is a need for the tube to be increased by 1 millimeter so that the strain when this 1 millimeter will be divided by the original diameter of 1.5 meters or 1,500 millimeter. Therefore, the strain would become 1 over 1,500. And what is this? What are these strain in X and strain in Y? So, alam natin na itong strain in X is actually the tangential stress of 18-volt pressure vessel. And that tangential stress is equal to the pressure inside multiplied by the diameter of the tube divided by twice the thickness. So if we're given the diameter, we are given the thickness, we can express therefore the stress along or the tangential stress in terms of the internal pressure inside the tube. And this will be equal to the internal pressure multiplied by 1,500 representing the diameter divided by 2 multiplied by 6 millimeter, which is equivalent to the thickness which is given here. So that in here millimeter will cancel, therefore the stress in along the x-axis will be equal to 125 P, so that if P has a unit of megapascal, therefore the stress would have the same unit as megapascal. And this value, stress in Y, is actually the longitudinal stress caused by the internal pressure on the tube. And we know that this longitudinal stress is equal to the product of the pressure inside multiplied by the diameter divided by 4 times the thickness. And so if we are going to substitute the value of the diameter and the thickness, therefore we shall be able to express the stress in Y or the longitudinal stress in terms of the internal pressure P. Hence, our stress in Y will be equal to 62.5 kP. So again, if P is expressed in megapascal, therefore the stress is also expressed in megapascal. Now, if we will be substituting these stresses in the formula, in this formula, that the stress over E is equal to the stress or to the product of the Poisson's ratio multiplied by the stress in Y over E. Again, this is the part represent the strain in X caused by the stress in the Y, which is equal to the product of the Poisson's ratio multiplied by the ratio of the stress in Y over the modulus of elasticity. Plus, again, this ratio of 1 over 1,500 represent the supposed to be stress along the x-axis due to the clearance between the tube and the hole. So if the stress shall be substituted with a value of 125 P and stress in Y with a value equal to 62.5 P, therefore we shall have the relation that 125 P over 200,000 is equal to 0.2 representing our Poisson's ratio, multiplied by 62.5 P divided by 200,000 plus 1 over 1,500. So from here, we can solve for the value P, so that the value P, which is actually the internal pressure inside, is equal to 1.185 megapascal. And let me explain this pressure. Ang ibig sabihin itong pressure nito, ito yung pressure inside, so that itong ating tube will just fit o kaya this hole. Ibig sabihin nun, yung clearance between them ay mawawala na. Okay? Because there was already a strain caused by that stress equal to the strain due to the stress in the y-axis plus that of the gap. The second question which asks for the stresses developed, particularly the tangential stress developed when the internal pressure is equivalent to 2.5 megapascal. So baka isipin natin na kay the stress, tangential stress can simply be taken using the formula that it will be equal to PD over 2T, just like when we have, okay, the computation of the stress along the tangent like this one. So tandaan natin na okay, itong 2.5 ay higit ng mas malaki dun sa stress that will cause okay, this tube to be just touch the wall of the hole. So akatwid, there will be additional stress okay, that would be induced on the material because there will still be okay, further reduction in the dimension due to the longitudinal stress developed because of the difference between the applied stress and the previous stress that we have just computed. And so if we're going to consider the same formula that we have, so that the stress index K over E will be equal to the stress to the strain in X caused by the stress in the Y plus of the clearance. Okay, the strain due to the clearance. You will notice that the stress index here is actually the unknown stress that we are looking when the stress in the Y, which represent the longitudinal stress, will be computed using the formula that it is equal to PD over 4T. So that okay, when the value of the stress along Y, which is actually the longitudinal stress, is computed, we have PD over 40. That gives us a value equal to 2.5 megapascal multiplied by 1,500 divided by 4 divided by 6 gives us a value of the stress in the Y, or the longitudinal stress, equal to 156.25 megapascal. And if this will be substituted in the formula, okay, that stress in X is to 2,000 E, which is equal to 200,000, this will be equal to 0.2 multiplied by 156.25 okay, divided by E plus 1 over 1,500. And from here, you have only one unknown, stress in X, which when computed will give us the tangential stress equal to 164.58 megapascal. At yan guys yung solution sa problem na nakita natin. Sana guys ay nasundan natin yung ating solution at nakatulong sa atin na maintindihan lalo itong axial deformation, particularly in the application of the Poisson's ratio in determining the deformation caused by a stress along one direction. Guys, huwag niyo akong iwan. Tuloy niyo akong subaybayan by subscribing to this channel and sharing it to your friends so that your friends will also be notified of this upload. Once again, thank you very much for watching.